Hi everyone, thank you. So I'm Tudor and I'm standing between you and lunch, and I know it's difficult. There were so many juicy pizzas there in Veliborg's presentation with the right amount of tomatoes and olives, and yeah, I'm hungry as well. So I'll keep it short. I'm a research scientist at UiPath in the London office, and yes, I'm an old guest of this summer school. I came here 3 times actually, and not because I'm slow, I hope, but the first time I was a student, and I want to make a short detour before talking the company I'm at now, because for me this was a life-changing event, and it might be for you as well. The first edition was in Cluj in 2018, and I was a student back then working in continual learning, and I was chasing Razvan on the hallway with, I had some formulas about the feature information matrix written on a napkin, and he was very kind to talk to me, and yeah, that's how I met my future PhD supervisor. And I'm telling you this because from time to time he takes new PhD students, so if you see that opportunity, don't hold back and write an email, and yeah, that could be life-changing for you as well. And if you want to know more about this, I'm very happy to tell you about my PhD experience at Imperial. So yeah, and I came back in 2019 as a teaching assistant, and actually we were co-organizers. The event was held in Bucharest, and the University Polytechnic of Bucharest, where I was a student back then, offered the venue, and then I had a chance to see actually how much work is behind this event, and how much the organizers and the volunteers sacrifice for this to happen. So I know that that it's reasonable for someone who presents to ask for a round of applause. Can you do it now for our organizers, volunteers, who basically sacrificed a lot of their times during the past weeks? And yeah. So, yeah, thanks for that. So, towards the end of my PhD, I did an internship where, for a very short time, I worked on reinforcement learning on controlling UIs, controlling computers. And that's when myself, who was passionate about reinforcement learning, found out about this problem, who's a bit different than your usual environment, like Atari, where your own goal is to, train this agent that would maximize some score, and yeah, basically after you write the algorithm, you're kind of done. But with controlling computers, it's a bit different because you want to still be in the loop, and it actually builds on that, and it goes towards building agents and assistants, and I guess it adds a level of complexity to the reinforcement learning problem that gets us closer to, let's say, general intelligence. So, luckily for me, after finishing my PhD, there was a Romanian company who worked exactly on that, and that's UiPath. So, less than a year ago, I joined the London office, and yeah, today I'm going to talk a bit about what we're doing at UiPath. I prepared these few slides with my colleague Dragos and Andrei, who are also here, and they made a mistake to let me talk, to do the talk. Yeah, so for you who don't know what UiPath does yet, besides, distributing ice cream, if you Google UiPath, you'll see that UiPath is concerned with robotic process automation. And it's a company that started in Romania almost 20 years ago, and now it has offices all over the world. I would want to single out that we do have AI teams that are growing in Seattle, in London, and in Bucharest, and that's what you should know for now. Now, if you wonder what robotic processing automation is, well, if you can imagine that some people during their office hours have to complete a lot of repetitive, tedious processes that might be easily detectable and that could be easily automated. So that's where UiPath comes in, and the gist of it is that we try to identify such a process, and then we define a workflow. And the workflow is then executed by robots, right? So that could be someone wants to do a spreadsheet with a report with all the invoices from the last month, right? So that could mean go open an email application, filter the relevant emails, download the attachments, open all of them, put them in a spreadsheet, and so on, right? So all these steps traditionally are designed by someone who creates the workflow, and then the automation happens, right? The execution happens by robots. But I would argue that now things are changing in automation, and this is the right moment, if you're passionate about this, to join the ship, because things are changing from this traditional robotic process automation to a more agent-centric approach, where we try to remove this need of someone defining the workflow, right? Which might require sometimes some domain knowledge. You might need to know some jQuery to specify the exact component you want to click on, while it would be more natural to describe it in English, right, in pure natural language. So I'm going to try to briefly go through some of the challenges we're facing during this transition, and where machine learning could help, right? Especially the new era of large foundational models. So one of the, actually, where does the RPA, robotic process automation, start? It starts from perceiving what's on the screen, right? It could be the screenshot of your whole desktop with several apps, or just some website that runs in the browser. The first thing we need to do is to detect the elements we care about, and to understand what happens there. So traditionally, we would approach this with computer vision. We need to understand which are the controls, the elements you can interact with. We also need to detect all the text. Maybe there are some special elements that have a particular structure, like tables. And also, more important, to understand the relations between these elements, which are very natural for us, but maybe not as natural for a computer. So for that, we have a very interesting computer vision model that has a multi-scale visual transformer backbone, and then very specific prediction heads for all these things that I showed you. I will, just in the interest of time, I'm going to skip this, and I'm going to go to the challenges we are facing now when we try to make things a bit more abstract. So one of the problems with this computer vision part is that the set of elements you care about is a living object that changes, and it's made of concepts that are overlapping. A thing could be at the same time a button, a date time picker, and so on. So it's a departure from your usual multi-class classification problem. Also, I was saying that we would want to refer to the objects on the screen in a more natural way that requires less technical skills. So one of the things we're working actively on is this concept of semantic selectors, where you, instead of giving a precise technical description of a button you want to click on, you actually have a more robust description, functional description of, in natural language, of what you want to achieve, right? So the next button could change, right? Could just become a small arrow, or a green button, which we now agreed culturally that means go to the next page. So those things are changing, but the function of it doesn't. So we would like to describe our workflows in a more natural way. So that's one thing we care about. Also, for this perception part, there's a problem which is very specific to our products, or maybe to the industry. So we have a model that's being deployed, and it has some kind of accuracy we are aware of on the training test and the test set, but actually there are a lot of out-of-distribution examples and queries that happen at our clients we are not aware of, and the model works in a particular way there, right? It has some performance, and we would like, when we update our models, to be consistent with the out-of-distribution predictions. And this is a very interesting problem, which you should chat more about with Dragos, who leads this computer vision effort. He's the guy with the ponytail and the scary beard, but actually he's a very kind guy, and he likes to talk about mountaineering and climbing and computer vision. And yeah, what I showed you, that model that I showed you, it's actually the result of many years of work, and he has very interesting insights in computer vision. So chat with him, and you know, maybe he can answer some of your questions, or if you're more knowledgeable, he might extend you an offer. So I don't know. Right. Another thing we care about is documents, right? And understanding the structure of documents. So we started leveraging large language models for this. We have an interesting application where we taken a document, and sometimes documents have structure, right? A PDF has an internal structure you can use to create a prompt for a language model. But if you have an image, you'd have to go back to this model, extract, predict the structure, and try to align it with, render it, and try to align it back with your visual, with your initial image, which is the document. So we have this interesting step of extracting, predicting the structure of a document, and then we prompt this into an T5 model, which then is able to answer questions about the document. And yeah, this is something that is quite interesting, and there are a few challenges here about how complex the questions about the documents can become. But what I want to talk more about is on this path towards agentic automation and the challenges we're facing there. We have this, we have a product which is called the UiPath Studio. It's like VS Code, but for people that write workflows, right? Those people that work on defining, right, the process in every detail such that it can be executed by robots later, right? So we have an effort to actually create that workflow directly from a natural language description of the task. And the interesting bit here is the way we do in-context learning. And you can imagine that you have an example like I told you before, where you have to interact with your email application and then with the PDF reader and maybe with your folder explorer and the spreadsheet, right? So there are a couple of applications that are interesting there and need to be used. And what we're doing, we're looking in our database of pairs between natural language descriptions of tasks and workflows, and we are looking for those which use this application, and we try to create the optimal set of demonstrations that we can put in the prompt, such that we can then get a workflow autoregressively for our current case. So my colleague Adrian, who's around here, leads this effort, and you can chat with him about it. Another interesting thing we're trying to solve right now is the following. Imagine you have a large company, and employees work on some stuff where there are repetitive patterns, right? There are some patterns, there are some things that repeat often, and you would want to detect those and automate, right? So one problem we care about is discovering patterns in recordings, which are basically videos, right? So we try to find those patterns. Now, this problem is quite difficult because you have low signal to ratio signal to noise ratio. And that's because, people start multiple tasks, they come back, they switch context, and sometimes, external information is used. So that's one of the challenges. And the second is that sometimes it might not be obvious for a single person that a process they are doing is worth to be automated. But if you look at a larger group, right, it could be something that everyone does for 10 minutes every day, right? So there is a potential to make people more efficient, or just to make the whole process more efficient by looking at the larger data. And of course, the goal here would be to look at such recordings and propose tasks which can be automated and actually extract a workflow from that video, right? So maybe like solving an inverse reinforcement learning problem. Right. Now, I'm very happy to spend a few minutes talking about the project I'm working on. So less than a year ago, we started this research team in London, which is called Project Foundation. And our goal is to see how far we can get with models trained end-to-end to shortcut everything that I showed you so far. So our goal is basically, given some kind of screenshot and a task described in natural language, we should come up with a policy, with an action that drives automation. So we don't know exactly which are the right approaches here. So it could be a multi-agent system. It could be some kind of hierarchical organization. There could be tools used. But what we care about is to have this general agent that it's capable to learn in context from a demonstration, to understand how to explore a new environment. Let's say your agent knows how to use all Office products, right? But there's a new one coming, and there's a new app that we didn't have in the training set, and then the agent explores it for a while, and then knows how to execute and solve problems there. Right. So if you are familiar with this, I think 2 days ago with the Visual Web Arena, this is basically the prototype problem we are trying to solve. In order to leverage the data we have at UiPath, where we do have such trajectories, and sometimes it's easy to define an algorithmic solution to it, we tackle this mini-web problem in a different way. So instead of doing reinforcement learning and training agents to solve it, we defined a couple of algorithmic solutions that generated trajectories, which was even simpler than doing the task ourselves. And we did synthetic trajectories with trained agents with behavior cloning, and we got on par performance with DRL algorithms. And this kind of validates the scenario of imagining problems, solutions to problems, generating trajectories and using those. Synthetic trajectories could be as good as human trajectories. I won't bore you with the model right now, but okay. This is unexpected. We won't solve it now. But I had a very nice demo with our action agent. It is a demo Andrei, my colleague, worked on, and you should chat with him about it. We have this, we envision this agent, which, as I told you in the beginning, works along with the user, and you have this triangle. You have an environment, you have a user, you have an agent, and basically everything happens asynchronously. You can give the agent a task like do my taxes, right? And then you just sit and watch how the agent starts doing that, and you can correct it, you can steer it. Oh, you forgot a couple, or try to put less. Right, I'm sorry for this. We won't spend time now to fix this problem, but chat with Andrei. This is a very cool demo. Now, in terms of research, most of the models we showed you are transformers, so it's only natural that our more research efforts go into exploring this architecture and maybe trying to find better ways to compute what we need to compute or to express what we need to express. So I'm going to briefly go to one of the papers our intern Raresh worked on. It's called Latent Attention for Linear Time Transformers. And what it tries to do is to give a probabilistic interpretation of the attention mechanism and provide a replacement for that, which is linear in time. And the main difference is, if you look on the right column, on this, the second formula, which introduces these latent variables, those P of S given L. So what we care about here is how we introduce some latent variables, and we have now the attention expressed as a marginal probability, right? Now this reduces the complexity, the time complexity and the memory complexity of attention. And from our experiments, it's not only faster, but also on par on performance with attention, at least on the data sets we ran so far. So this paper will be presented by Raresh next week at EEML at the Advanced Architectures workshop. So you can find out more about this there. A second paper at the same workshop by our same intern, who's very, very efficient, is called ROT-RNN. And I think this comes great after the talk you heard this morning from Razvan about SSMs and linear recurrent units. Basically, this offers another parameterization to the A matrix. So if you remember from this morning, we have this discretized SSM perspective of recurrency, right? And there's this A matrix. And the linear recurrent units try to use a complex representation that tries to normalize things such that your X vectors don't explode, which are kind of intricate. So Raresh found a better way to do this by constraining the matrix A to be a rotation matrix. And there are a few advantages from this. Your eigenvalues will be always 1. You don't need to enforce that in other ways. And also, because these rotation matrices are orthogonal, you have a simple way to normalize, to do the normalization with a single scalar. Yeah, and also the parameterization of this rotation matrix is simplified by the fact that you can just create a block diagonal matrix where you put those, your traditional cosine sine rotations. Right, and this, yeah, sure.
Yeah, just the citation. Is this supposed to be 2027?
No. No, I wrote that by hand because I'm not sure how to do a proper bibliography in Google Slides. So, yeah.
I just wanted to point it out.
Yeah, no. We're still in 2024. No. I mean, this was a bit boring maybe, but we didn't sleep for so long. Right. Now, the interesting thing is that if you want to create different parameterization, we just have to come with different decay parameters. And this worked really well for us, at least on the long-range arena task, where the rotation RNN is basically on par with the linear recurrent units, maybe slightly worse on some tasks. We couldn't train it on path X. I'm not sure if you're familiar with this task. Basically, path X gives you an image where there are some paths, some curves that you need to follow. and you have to say if 2 points are connected or not. And the image is served pixel by pixel in a 1D sequence. So it's quite a hard task, and yeah, this is the only one that our approach couldn't solve. Now, it's not a secret for now that Colin is not an ice cream vendor. He's actually our senior talent acquisition partner. And yeah, we're hiring, and that happens across the world. We have offices from California, Seattle, New York, London, Bucharest, and others. And yeah, if anything that I presented you today is interesting to you, please chat with Colin, and yeah. Thank you so much. Hvala, and yeah, thank you so much.